You know, every single day, with every click, we're sending little pieces of ourselves out across the internet. But where do they actually go? And how in the world do they stay safe? Today, we're going to pull back the curtain on that invisible journey our data takes. We'll look at the dangers it faces and the really complex defenses that protect it.
Think about it. It's something we do probably 100 times a day without a second thought. You see a link, you click it. Boom. But what happens in that tiny fraction of a second between your click and the page loading? Well, that journey is way more complex and honestly more fascinating than you might think. So let's follow the path, right from the very first step. Okay, so every story has a beginning. Ours starts with the departure, the exact moment your request leaves your own local network. So what is that starting point exactly? Well, a network is really just a bunch of interconnected devices. The easiest way to think about it is your digital home base. Your laptop, your phone, your router, all chit-chatting with each other to share one super important resource, your internet connection. The instant you click, your request doesn't just zoom off as one big file. Nope. It gets broken down into these little things called data packets. This little packet, it's the hero of our story. And its roadmap, the thing that guides it, is a set of rules called the TCP/IP protocol. That's basically the fundamental language of the entire internet. All right, so our little packet has left the safety of your home Wi-Fi. It's now entering what's kind of like the Wild West, the open internet. And just like any open road, there are some serious dangers out here.
The very first choice our packet has to make is which road it's going to take. And this is a perfect way to picture it. Taking an unprotected highway, or HTTP, means everything inside that packet is out in the open for anyone to see. But a secure tunnel, HTTPS, encrypts the data. It wraps it in this cloak of privacy that makes it totally unreadable to any prying eyes.
So what kind of bad guys are lurking out there? Well, let's look at this. A man in the middle, or Mitmam attack, is exactly what it sounds like. It's like someone eavesdropping on your conversation on that open highway. DNS poisoning is even sneakier. That's like an attacker literally changing the road signs to send your packet to some malicious website instead of where you wanted to go. And IP spoofing. That's the digital wolf in sheep's clothing. An attacker pretending to be someone or something that you trust.
Okay, so let's assume our little data packet successfully dodged all those dangers. It finally arrives at its destination, the web server. But getting inside? That's not going to be easy, because this place is designed and defended like a digital fortress.
Now, the main strategy protecting this fortress is a concept called defense in depth. The idea is actually pretty simple, but it's incredibly powerful. You just don't rely on a single defense. Instead, you build multiple, layered security controls. It's not about having one tall wall, it's about having a series of walls, and moats, and guards.
And the very first of those walls is the gatekeeper, the firewall. A firewall is a security device, and its whole job is to stand at the border and inspect every single packet trying to get in or out. It's got a super strict set of rules, and if a packet doesn't have the right credentials, it is not getting in. End of story.
But hey, what if something does manage to slip past the main gate? That's where the security patrol comes in. These are intrusion detection and prevention systems. An IDS is like a guard who spots suspicious activity inside the castle walls and sounds the alarm. But an IPS, that's a guard who not only spots the trouble, but has the authority to step in and shut that threat down on the spot.
So the fortress is pretty well defended against individual threats, right? But what happens when it's not just one attacker, but an entire army laying a coordinated digital siege?
Well, that's what we call a denial of service attack. And the key thing to understand is that the goal here isn't to steal your data. It's pure disruption. It's about overwhelming the system so much that it becomes completely unavailable to legitimate users, like you and me.
And the scale of these attacks, it's just staggering. I mean, we are talking about a flood of data measured in hundreds of gigabits every single second. It's the digital version of millions of people all trying to cram through a single doorway at the exact same time. The whole system just grinds to a halt.
So how does the fortress possibly survive this? Well, it fights back with a three-step defense. First up is traffic filtering, which is basically blocking known bad guys right at the gate. Next is something called traffic scrubbing, where you use specialized services to analyze that flood of data and literally scrub out the malicious parts. And finally, network hardening, which is all about reinforcing the fortress itself to make it more resilient to the strain. So, our data packet has reached its destination and done its job, but the journey isn't quite over. we still have to make sure it gets a safe trip home, and we need to lock in the key principles of its protection.
That response from the server, the actual web page you wanted to see, that data needs the same level of protection for its return journey. This is where a VPN, or a virtual private network, comes in handy. It creates a private, secure, encrypted tunnel just for your data to travel back home, keeping it safe from any eavesdroppers on that public internet highway.
But let's be real, no defense is ever perfect. So, what happens if a breach does happen? Well, that's when a pre-made incident response plan gets activated. The goal is to act fast, isolate the threat, contain the damage so it can't spread, and then start the careful process of restoring everything back to a secure state.
So, after following our data packet on its pretty epic journey, what are the big takeaways here? First, security always needs multiple layers, that whole defense in depth idea. Second, using an encrypted path like HTTPS is absolutely crucial. Third, that Digital Fortress needs constant monitoring to spot trouble. And finally, you have to have an incident response plan. It's just non-negotiable, because no defense is ever perfect.
And that brings us to our final thought. Our data is protected by all these incredible layers of technology. Firewalls, encryption, all these monitoring systems. But as you go about your day, clicking links and browsing the web, it's worth asking yourself, is the most important layer of defense all that tech, or is it you, the user?